In a span of just 3 years, humans went to the moon 6 times in total. From the first trip in 1969 to the last one in 1972, 12 people were able to step on our satellite altogether. People who lived through that era had the impression that visiting the moon would become very common, and that witnessing this fascinating journey would become a frequent event from then on. That's not what happened. The truth is that more than 50 years have passed and no one has set foot on the moon again. But why? Why have we never gone back? To understand the reason why humans have not gone to the moon again, we first need to understand the reason why they went to the moon. And that reason is called the Cold War. Recapping this page of history quickly, we can say that after World War II, the United States and the Soviet Union began to compete for global hegemony in politics, economics, and all imaginable aspects, both here on Earth and in space. And despite the Soviets being the first to send a satellite, the dog Laika, a man, a woman, the first spacewalk, the first docking of 2 vehicles, and the first space station, it was the Americans who won the grand prize of the space race, the arrival on the moon. By planting the United States flag on the moon's surface, it became very clear who the winner of this contest was. And to leave no doubt, they went back another 5 times. Traveling to the moon became so routine that many people lost interest in following the moon landings. It reached a point where the American government realized it no longer needed to prove anything. The cost of sending humans to the moon was very high. With all these factors, plus popular pressure to spend less, the lunar program ended up being suspended. What people do not know is that although it ended, the Apollo program left a legacy of great scientific advancements, not only for space exploration, but also for our everyday lives. Want some examples? Wireless tools were developed so that astronauts could drill the moon's soil even without a connection to the base. And thanks to this, today we have everything from cordless drills to vacuum cleaners. The suits used by firefighters also emerged during this time. After the launch fire of Apollo 1, which killed 3 astronauts, scientists developed a flame-resistant fabric made with synthetic fiber still used today. You can also notice the impacts of Apollo on health. NASA's research to purify water over long periods led to the significant improvement of hemodialysis machines, which are used today to filter the blood of people with kidney problems. And some exercise machines used in gyms and sports clubs originated from equipment created by NASA for astronauts to use during periods of zero gravity. And you know that frozen food that saves our lives when hunger strikes and we're too lazy to cook? We also owe a thank you to the Apollo program, because it was due to it that scientists developed methods to dehydrate and freeze food to reduce weight and increase the shelf life of food. But even with all these advancements, the fact is that indeed the Apollo program came to an end in the early 70s. Since then, in these last 5 decades, there have been plans to resume the trips, but they always encountered the economic obstacle. At the beginning of this century, American President George Bush even announced the resumption of the lunar project. But his successor, Barack Obama, didn't want to spend the more than $100 million that this journey would cost. Similarly, other politicians agreed it was necessary to address the problems here on Earth instead of returning to the moon, and thus the idea ended up being shelved on several occasions. The budget for NASA projects has been cut every year. While back in the 1960s the space agency received almost 5% of the entire US government budget, today that figure is no more than 0.5%. And with that, NASA's own performance has changed a lot since then. In the meantime, the agency focused its efforts on launching the International Space Station and more powerful satellites, such as the Hubble and the James Webb. And these 2 satellites have no easy objectives. We basically built them to explore the origins of the universe. So instead of sending humans to the moon, we started sending probes into space. And this strategy makes sense. It is cheaper and safer. It is much better than sending humans to a deadly environment. Space is not easy. On the other hand, this decision has a problem. Sending probes instead of humans is, to use a non-technical term, much less cool. Seriously, we would love to see humans landing on the moon again. Especially because for everyone under 60 years old, like me, it would be the first time. Imagine how exciting it must be to turn on the television, gather friends, and watch live as humans land on the moon. The good news is that after all this time, it is finally going to happen. Humans are going back to the moon, but if there were so many obstacles in recent decades, why are we doing it now? Why are we going back to the moon? Just like during the Cold War, the United States has started a new space race in recent years. But it is not about Russia this time. This time, the competition is against China. And it's not me saying this, it's the NASA director himself who is the astronaut Bill Nelson. The Chinese have already announced that they intend to reach the moon before 2030. And the Americans, as we know, don't like to be left behind. That's why they plan to set foot on the lunar surface as early as 2026. But why do they want to return to the moon? Why do both the Chinese and Americans, and humanity as a whole, have an interest in starting a new space race towards our satellite? Perhaps the main answer to this question is, in fact, helium-3, known as the fuel of the future. Helium-3 is an isotope of helium, meaning it contains the same number of protons as helium, but has a different number of neutrons. While the original atom has 2 protons and 2 neutrons, helium-3 has 2 protons and only 1 neutron in the nucleus, in total. Its existence was proposed 90 years ago, but it was only in recent decades that scientists began to observe its enormous potential as an energy source. And this is possible thanks to nuclear fusion, the process where 2 atomic nuclei combine to form a new nucleus with a higher atomic number. This process requires a lot of energy, but it also generates a lot of energy. In fact, it is through nuclear fusion that stars obtain their energy. But for commercial use, we only know how to do nuclear fission, which is the opposite of fusion, where heavy nuclei are bombarded with neutrons to be split and release energy in the process. Currently, there are no commercial fusion reactors, and we don't even have fusion reactors connected to an electrical grid. All nuclear fusion is conducted experimentally, and the main fuel is the hydrogen isotope extracted from seawater, deuterium, which is a hydrogen with 1 proton and 1 neutron in the nucleus. Energy production by fusion is much safer and does not generate any long-lasting nuclear waste. Even so, conventional nuclear fusion still creates short-lived radioactive waste, both tritium, a radioactive hydrogen isotope, and through indirect neutron bombardment. The material forming the reactor can absorb these neutrons and generate radioactive isotopes in the process. And that's where helium-3 comes in. When it is used instead of one of those hydrogen isotopes, the energy is immediately released in charged particles without producing neutrons. As a result, the reaction does not generate radioactive byproducts. It is a much safer process with no risk of contamination. It is the ideal way to generate clean and super powerful energy. But if helium-3 is so wonderful and has all this revolutionary potential, why isn't humanity already using it as fuel today? Excellent question. The problem is that helium-3 is extremely rare here on Earth. It is found more easily exactly where you thought, on the moon. That's because for billions of years, the action of solar winds spread helium-3 particles through space which fell on the moon. Okay, but why didn't they fall on Earth? Because of the atmosphere. The Earth's atmosphere acts as a protective shield. It is essential, blocking radiation to Earth, but it has prevented this rain of helium-3 over Earth's history. The moon, however, does not have an atmosphere, which is why helium-3 is much more abundant there. But still, it's not like it's something extremely common. You can't just pick up a piece of the moon and see that it's full of helium-3. The concentration is approximately 4 parts per billion of the lunar soil. Therefore, very advanced mining work is needed on the moon, which is obviously a great challenge both financially and technologically. But at the same time, it can be extremely rewarding. Jupiter and Saturn also produce helium-3 in their atmospheres, and we can potentially consider the possibility of collecting it somehow for use in future activities, such as asteroid mining. This is because helium-3 can be used, for example, in rockets powered by nuclear fusion, which would be even more powerful than current rockets. And with that, the exploration of helium-3 would allow for unprecedented advancements in space exploration. Transporting helium-3 to Earth can be very expensive. So the idea of these projects is to create a new fixed base on the moon, a kind of interstellar fuel station, where rockets could refuel to start journeys much farther than one could imagine. And that is the idea behind NASA's next mission to the moon, to create a starting point for the future conquest of Mars. And now I am talking about the Artemis project. In Greek mythology, Artemis was the twin sister of Apollo, which, if you ask me, is a very fitting tribute to the mission that took people to the moon a few decades ago. But this time, more than just a female name, NASA will also take a woman on this mission. She is Christina Koch, who, along with 3 other men, including the first black man to go to the moon in history, will travel towards the moon soon. But how will the Artemis project work? The first part of it has already happened. The Artemis 1 mission launched in 2022. It was an uncrewed flight that was just for testing. Artemis 2 was supposed to happen now in 2024, but it has been postponed to 2025. And this is due to some technical problems, especially in the circuit responsible for air ventilation and temperature control, which is crucial. And this journey will be manned with the astronauts I just mentioned. But they will not land on the moon yet. They will only orbit the moon and return to Earth. And then, if all goes well, the long-awaited Artemis III mission will take place in 2026. And it will be on this mission that a human will finally set foot on the moon again. And I'm really excited about it. And even after this trip, there are already other missions planned. Artemis 4 will serve for the assembly of the Lunar Gateway, which is a space station that will start orbiting the moon. In all these journeys, the astronauts will stay aboard the Orion capsule. It will be docked to the SLS, which is the Space Launch System. It is the most powerful rocket of all time. It weighs 2.7 million kilograms, with more than 2.3 million being just fuel, which is liquid hydrogen. This space giant will launch the astronauts' capsule on a journey of approximately 380,000 kilometers over 3 long days towards our natural satellite. And then, you, me, and our entire generation will finally be able to say that we saw a human being land on the moon. But what if we don't just want to watch? Is there any possibility that someone who is already alive today, maybe even watching this video, could visit the moon someday? The honest answer is, I don't know. It is impossible to pinpoint exactly when ordinary people will be able to visit the moon, but to at least try to make a prediction, the technology site Gizmodo, founded in the United States, asked several experts what their expectations were about the possibility of common citizens going to the moon, and the answers were quite varied. For example, the director of the Global Space Center at Cleveland University, Mark Sunhall, expects that by the beginning of the next decade, there will be lines forming to take a trip to the moon. However, the specialist in the history of technology at Duke University, Alex Holland, says that it certainly won't be in the next 50 years. And the professor of advanced air and space studies at the American Air Force, Wendy Cobb, believes that this might only happen at the end of the 21st century. In other words, there are many different possibilities. But almost everyone agrees that sooner or later this will happen, at least for those who have a lot, and I mean a lot of money to make this trip. There are already some private companies offering space flights. Okay, they don't get anywhere near the moon, but the prices are still exorbitant. In the case of Virgin Galactic, for example, tickets for a space flight have already been sold for $450,000. Blue Origin auctioned a seat for $28 million. And the winner of the bid had to be replaced because he had an important scheduling conflict on the day of the significant launch event. And I just keep on wondering, what kind of very serious commitment is more important than actually going to space? This is a growing market. More and more companies are entering the space tourism sector, such as SpaceX, founded by Elon Musk. It wasn't created with this goal in mind, but it is gradually moving into this field. In other words, it's clear that space tourism is already a reality for normal people. If you consider being a multimillionaire normal, who am I to judge what is normal or not? I am just a person who makes videos for YouTube on a science channel. But regarding the moon, besides the financial and technological aspects, some other challenges need to be overcome for visits to become possible and frequent. New laws will have to regulate the sale of this type of tourist package. International treaties will need to define the rules for these expeditions. And even some details that might seem irrelevant will be crucial. For example, we will need to define a lunar time zone. Nowadays, we don't know what time it is on the moon. But with so many arrivals and departures, it will be essential to determine how time will be marked there. And after all these issues, both the simple and the complex ones, are finally resolved, then it will be possible to witness another exciting chapter in the history of people who dreamed of exploring the universe. Thanks to our adventurous spirit, we will be able to go to other planets. And who knows where else the future will take us. That's why, first, we need to go back to the moon. It will be the great starting point for the next stages. And it's exciting to know that this journey is about to begin. From the philosophical aspect to the scientific, space conquest is probably the most impressive achievement ever accomplished by human beings. It's truly incredible to think that an animal that left the caves of Earth gathered only the pieces it found here and managed to launch itself into space. And it's even more fantastic to think that this journey is just beginning. With the unpredictable advances in sciences, the vast distances of space are being increasingly overcome. The mysteries of the universe are being revealed, and what seemed impossible is becoming real. One step at a time, we are experiencing a new and very giant leap for humanity. Thank you very much, and see you next time.